This week on BSD Now, it's finally here. The episode you've been waiting eagerly for and been asking for and bugging us about nonstop. We're giving you a crash course on becoming a ZFS wizard, as well as having a chat with George Wilson about the OpenZFS project's recent development. So it's pretty much ZFS now today. It's going to be awesome. We have answer to your feedback emails, and there's some other great news items to get caught up on. So stay tuned to BSD Now, your place to be, SD. BSD Now, episode 14, recorded on December the 4th, 2013. Hi, I'm your host, Chris Moore.
And I'm Alan Jude.
Hey, we're glad to have you guys with us this week. We got a great show coming for you today, a really cool interview we're going to do a little later, and of course a tutorial. But before we get into any of that, let's start off with the weekly headlines. So first up, we have a package NG 1.2 has been released for a free BSD. Now, is that in? They haven't brought that to Dragonfly.
Actually, they have. It's now been imported as well.
So they rolled in Dragonfly as well. So Baptiste and Brian Drury from the port manager team just released 1.2 final this last week. So if you update your ports and start rebuilding stuff, you'll notice that that's going to get updated on you. Yep. Some of the new features we have include an improved build system, plugin improvements, new bootstrapping command, some improvements for the server mirror improvements, and new package config command, repo improvements. Gosh, everything's been improved, it sounds like.
The audit framework now uses VU XML, so it can tell when the package you have is vulnerable and you need to update it. And a new fingerprinting feature, which is for the new way they're signing packages.
Sure. So gosh, so just about everything has been improved or updated or tweaked in some way, it sounds like. It's really simple to go ahead and get you guys upgraded, though. You can always check our package NG tutorial if you want some easy instructions on how to switch over. And as we mentioned, it's already made its way into Dragonfly, so a little later today when we post the show notes, take a look and you can get a link to the full list of new features and fixes and new commands to play with. So what's the next item we have in the news roundup this week?
Next up is OpenSSH gets the new Cha-Cha and Poly 1305 encryption stuff.
What does Cha-Cha stand for?
Cha-Cha 20 is a cipher developed by Daniel Bernstein, the guy that did Qmail and stuff. He's kind of known for being really good at the security type stuff.
Sure.
And the problem they had before is RC4 was used because it was really fast, but now that we know that the NSA likes to break that really easily, they're like, how do we do something else? And so they've been using this, AES-GCM, but there's a couple of different ways to approach doing the encryption stuff, because on top of just encrypting the data going back and forth, you also want to authenticate it and make sure it hasn't been modified while it's in transit. Because the only thing worse than someone reading your SSH commands would be them changing the SSH commands that you're sending, right?
Yeah.
And so they have a MAC, or a message authentication code, that shows that the message hasn't been modified. And there's 3 different ways to do that. You can take the original message and then take a MAC of it and then encrypt it. So you can encrypt then MAC, or you can MAC then encrypt, or you can encrypt and MAC, and a bunch of different ways.
Oh wow, a lot of variety.
And when IPsec, SSL, and SSH were invented, each one used a different one. And it's since turned out that there's kind of an issue with doing it the different ways. Leaks different bits of information. Anyway, so with with both the AES-GCM and the encrypt then MAC models, there's a small downside that because they're not decrypting the packets as they go, they need to know how long each packet is. So they'd have to transmit unencrypted how long each packet was. And so if one of those packets was, say, your password when you were logging in, someone could know how long your password was, which makes brute forcing it a lot easier.
Sure,
and things like that.
Combinations of 9 characters or something.
And things like that. So then they were looking at different ways of doing it. and they decided to come up with using Cha-Cha 20 with the Poly 1305 Mac, and to actually then encrypt the length of the packet separately using Cha-Cha a second time, so that they could hide it. It's not the end of how they want to do it. They want to take it even further, but this is what they have for now. So an attacker may still observe that encrypted packets on the network and try to ascertain their length. And right now, they're likely to be successful. And he says that he hopes to add some features to frustrate this sort of traffic analysis sometime next year.
Oh, okay, cool. We'll look forward to seeing when that arrives.
Damian Miller, one of the lead developers behind OpenSSH, has a big blog post about it that we linked to. And I think we're going to get an interview with him early next year as well. So that will be great.
Fantastic.
Yep.
Yeah, that'll be definitely an interesting one to hear, especially if you're at all interested in security and privacy.
I don't know anybody that doesn't use SSH.
Yeah, it's the default de facto standard. Yeah. I mean, shoot. I mean, what happens when you sit down on a Windows box? First thing you download is PuTTY.
Exactly.
Right? I mean, so you can SSH in.
Yeah.
Okay, so next up, we have an article written by IT World. It's actually pretty fascinating. Yeah. They did an article about switching from Linux to BSD. And the title of this is "It Time to Dump Linux and Move to BSD." So very appropriately titled. Basically, the author's interest was sparked from a review he was reading. And a quote we got from here is that, "I feel the BSD communities, especially the FreeBSD projects, are where the interesting developments are happening these days. Over in FreeBSD land, we have efficient PBI bundles, a mature advanced file system in the form of ZFS, which we'll be talking a lot about today, new friendly, powerful system installers, new package manager, package-ng, powerful jail manager, and soon there will be a new virtualization technology coming with the release of FreeBSD 10. So pretty much the whole article can be summed up with yes.
Yes,
okay.
Yes, and use PCBSD, actually, it seems.
Yeah. So that's actually really cool.
Yep.
So we're going to link to that, of course. Yep. Go ahead and definitely check that out. It's just an interesting take on the switching over from Linux to, I guess, PCBSD, FreeBSD, or other derivatives.
Yeah, and it talks about,
pretty cool.
Some of the stuff that's coming and stuff that's already here and why it's very useful.
That is cool. I thought it was really neat that they mentioned the PBI thing in there. Like, oh, wow, that's cool.
Well, I guess it's even more interesting when you're the guy that invented that, right?
Yeah. The reason I mentioned that is that was my baby and still is. So that's really cool. But anyway, check out that link after the show's done today, guys, and read a fascinating article.
Yep.
What we got next, Alan?
We have the slides and videos from the OpenZFS Developer Summit. So this was held at Delphix, I guess it was 2 weeks ago, I think, about. And they have over 6 hours of video of the various talks and things that went on. There was a bunch of lightning talks from each different vendor, just a little bit about what they do with ZFS and how they're contributing back and so on. Included in that was Justin from the FreeBSD Foundation and Alfred from FreeNAS and a bunch of other people. And there were also good talks about things like ZFS channel programs, which is this new feature they're looking at adding to be able to do atomically an entire set of operations. And actually, hopefully we'll get to talk to George a bit about that. But anyway, they have the slides and the videos from all that, including George's talk about performance on full and fragmented pools, which was a really good talk about why ZFS has problems when the pool gets really full and what he's done to solve it.
Sure.
They even have the slides and a ton of video.
Looks like about 6 hours worth of video.
There's quite a bit of video in there.
Yeah, that'll keep you busy for a while. Yeah. But if you're at all interested in ZFS on any of these different platforms, I'm sure there's going to be some cool stuff that you want to hear about. Which, appropriately enough, this is our last news story for the week, and is going to lead us into our interview, where we're going to be interviewing George Wilson of the OpenZFS project. So stick around. We'll be back with George in just a moment. This week, we're joined with George Wilson, software engineer at Delphix, who's here to talk to us about the OpenZFS project. Good to have you with us today, George.
Yeah, good to be here.
Great. Well, as usual, with our guests, we usually ask you the same question at the beginning. First, tell us a little bit about yourself, how you first got involved with ZFS, what kind of led you to this point.
Sure. So I actually started kind of playing around with ZFS in the early alpha days. So I was working at Sun Microsystems at the time and was primarily just a user. I was working in a different engineering group. And so I just started using it on some of my test machines and kind of really got involved with it, really liked it. Fast forward 2005, just after the open source integration, again, working in a different engineering group, I started talking to some of the engineers at the ZFS development team and started working on doing the integration into Solaris 10. So Solaris 10 was the first official supported release of ZFS that actually came out. I was the tech lead to actually get that integration in there. So myself and a team of 2 other people kind of took everything that was out in the open and got it into a shipping release and kind of sustained it for a few releases. And then shortly thereafter actually joined the ZFS development team full time. And kind of continued handling a lot of the integration into a shipping release, and then started working on a series of things. One of the things that I just kind of have always followed and still follow to this day is pool corruption. And so as a hobby, I've kind of done a lot of pool recoveries. I've probably, I guess, since I've been doing ZFS, I've probably done over 100 pool recoveries for various people from the community to customers, just as, like I said, it's kind of a hobby of mine. It's primarily a way for me to make sure that we're not introducing any strange things out into the community, and it gives me a chance to not only fix the issue, but also kind of make sure that the software is working the way we expect it to.
Cool. So what features have you worked on in the past on ZFS? What can we blame you for?
So there's probably quite a few. One of the very first things that I started working on, which not a very well-known feature, is this ability to do reallocations. So if for some reason you had a device kind of fail or possibly go offline for a few seconds, in the event that you had actually allocated a block from that device, what would happen is when we tried to actually issue the write, because it was now offline, it would fail, and typically the pool would just suspend. So we wanted a way to make a determination of, if there were other devices still accessible, could we just simply reallocate somewhere else? So that was one of the very first projects that I worked on when I joined the ZFS team, was doing that functionality. It's kind of happens under the covers. Nobody really sees it, but there's a lot of functionality that we're trying to move blocks around. I guess from there, I started working on auto expansion of devices, so the ability to actually expand a LUN if you have a smart storage array that has that capability, so that you can grow it without taking the pool offline. I worked on the framework for device removal. Currently, the only thing that you can remove are log devices that are considered cache devices, and spares you can remove, but log devices actually take on a different characteristic within ZFS. I guess more recently, or I guess right before I left Oracle, I guess one of the last things I worked on was dedupe. I worked very closely with Jeff Bonwick on dedupe and kind of getting that to a point where it was mostly usable, so you can blame me for problems there, as well as booting ZFS. And again, all these were kind of based on Solaris. I know the boot infrastructure varies on platforms. And then my time at Delphix, I've been working on a feature called single copy arc, the ability to actually only keep one copy of a block, even though that block may be shared by multiple file systems. We only keep one in memory. I worked on a little known feature called not write. This is kind of like a very fast pseudo dedupe. Very good for backup applications. So the idea and premise behind it is, if you have say a block that was written, and later on you take a snapshot and then you back it up and you back up the exact same contents of the data, instead of actually making another copy like you would with copy on write and consuming more space, it simply detects that that block hasn't changed and just simply doesn't do the write at all. So you're saving space if you're always kind of backing up data that maybe could be static. Let's see. And then I guess recently I've been doing a lot of performance work on imbalanced LUNs. So cases where you have pools that have devices that might be mostly full and some devices that are mostly empty, and looking at, how free space is or how free space is comprised in your pool, ways to actually observe that, and ways to improve the way we do allocations of blocks on devices.
So right, because
kind of some very interesting fragmentation and full pool kind of performance issues.
Right, because in most people's situation, they're going to have a pool and it's going to get full, and then they'll add a second VDEV of disks, and then the problem is with the unbalancedness you have. Unless you've got your data divided up into nice chunks as separate data sets that you can try to manually move around to rebalance them or something, you're going to have quite a few issues, right?
Exactly, because ZFS will, as soon as you add that new device, ZFS will automatically try to stripe your data now across, all devices, and it finds that trying to allocate on devices that are pretty full can take a lot of CPU cycles, so you end up burning a lot of time and it gets kind of slow there.
Yep.
Sure.
So you trade off some of that CPU and I/O bandwidth. Really, you're trading off for a faster write, better, hopefully better performance by kind of avoiding some of those devices that are full.
Well, cool. Well, what platform do you actually use ZFS on personally, and what tasks are you using it for?
So I've been using Illumos primarily because that's the platform where we did most of our development. So I kind of use it as a way to, to kind of do backups and home file sharing. Also use it obviously at our office and our work. We have it on build servers and things like that. But mostly for me personally, it's all been just kind of using it for backups, and I have my home directories on it. So we have several different computers that we can actually get access to that files. And I've been using Illumos just as a safety net to make sure, again, as things go upstream and we get combinations and changes from a much larger contributor base than we do just from our company, I can verify and do some testing at home.
Right, some kind of dog fooding it and things like that.
Exactly, yeah. Although, the FreeBSD version has been very good at keeping up to date with what's out in Illumos, so I've actually considered switching over to that as my home server just to get a feel for how things are behaving in other platforms that I'm not familiar with.
What's different and how the changes affect things.
Exactly.
Do it.
Well, I may ask you guys for some advice.
There you go.
So can you tell us a little bit more about what exactly the OpenZettabytes project is actually about?
Yeah, so, when Oracle actually closed source ZFS, it kind of created this, period of time where people weren't really sure what the future of ZFS was going to be. And myself and Matt Aarons, we always knew that there was going to be a bigger future, and we wanted to kind of make sure that we expanded on that. So very early on, when he and I both joined Delphix, we started talking about how can we actually get the community more involved. And the OpenZFS project kind of, I guess, started unofficially several years ago, and it wasn't until this year that it was officially announced when Matt announced it, I think at Linux Con or something. And the whole idea behind it is trying to get all the platforms together in as kind of one meta community. So we're not asking everybody to kind of get rid of their own, distribution list, but what we're looking for is initially for developers to kind of come together under the OpenZFS platform so that we can share ideas and collaborate and make sure that, we're not really duplicating effort. And at the same time, we're trying to really push the awareness that ZFS, in the open is alive and well, and thriving. I mean, I think, when you look at the amount of, commits that are happening from FreeBSD, to Linux and Illumos, it's pretty miraculous. And then, Mac has now come into the picture, and we're shortly adding kind of a fifth platform in OSV, which is a FreeBSD derivative, but they have kind of their own requirements. And so we're really trying to make sure that all these players out there are aware of each other and what they're doing. And it also gives the developers the ability to kind of communicate amongst themselves, ask about issues or problems that they might be seeing on one distribution. Because it is very hard for us to, like, for example, if I make a change in Illumos and when that gets ported back to a Linux distro, what actually happens in that environment? Maybe the merge didn't go correctly, or it behaves slightly differently. Something, I made an assumption that maybe they weren't aware of. This is a way for us to be able to collaborate and make sure that we provide consistent, performance and functionality of ZFS across all platforms.
Right, you're making sure that ZFS is ZFS no matter which operating system you're using it on.
Exactly. Exactly.
One of the other,
we're not all having to solve the same problems over and over again on each different flavor.
Right.
But also just from the user's perspective, as making sure the commands are the same no matter what the platform is.
Yeah, and that's an excellent point. I mean, one of the things that we've been challenged with, and I think every platform has kind of dealt with this slightly differently, is dealing with the physical sector sizes, especially as we're getting into like 4K devices. Everybody has chosen to kind of handle that solution slightly differently, and one of the things that we're trying to do now is actually come up with a combined solution so that all platforms and get the same administration model. And it all behaves the same.
Yeah, and as an end user rather than a developer, that's really important to me. And also just
to interrupt, Alan, some people are saying that the feed died online. I'm not sure
it's
if
still going.
Still going? Okay.
Yep.
Okay, cool. We are recording.
Yes, that's all that's important.
There you go. Okay. Well, cool. Sorry to interrupt with that. But
definitely the administration model is a key thing for us. We want to make sure that across all platforms we keep that consistent so that people that become familiar with ZFS on Linux can know exactly how it will behave on Mac OS or FreeBSD or whatever.
I'd like to see it become the default de facto file system. I mean, if I have an external drive, even, it's ZFS, no worries. I can mount that and do what I need to do on any OS.
Yes. We would love to see that too.
Yeah.
Very cool. So what specifically do you hope the future of OpenZFS is going to bring to the community?
I think one of the things that we're striving for and we're actively working on right now is trying to come up with a common repo. We just had our OpenZFS Developer Summit just recently, and we've known that one of the biggest problems has been having these various platforms take in changes that come in from some other platform. So we're really trying to come up with a way to make that simpler. That way, we don't have a Linux distro that's lagging several months behind simply because they're having to work through all the merge changes and the incompatibilities because I may have decided to use some specific kernel primitive that doesn't exist in Linux, and so now they're having to figure out how to either incorporate that or rewrite it or what have you. So we really kind of want to come up with that as our first main kind of big milestone. And along those lines, we know that every platform is going to have to come up with a porting layer. So this is where we're kind of relying on the different developer communities to kind of come in and say, okay, yes, I understand what what that particular kernel primitive needs to do on FreeBSD or on OSV or on Linux, so they can actually contribute to the porting layer once we can kind of define what those interfaces should all look like. So that's kind of what I want to see OpenZFS strive towards. And then I think we're well underway with getting the developers kind of in touch with each other. And hopefully going forward, we're going to see more like administrators actually coming to the table and kind of voicing their opinions of what they would like to see, across the board.
I can definitely offer some some opinions.
A lot of the recent changes have been really helpful, like being able to do get on properties recursively to see it through a bunch of stuff, or just the ZFS send and receive verbosity, or being able to do a no-op version of a delete a snapshot recursively and tell me how much space that's going to save or whatever. All that stuff has made a big difference. I call them the ZFS quality of life improvements. They're just tiny little things of the commands that really probably weren't even that much work, but they just make my job so much easier and make it so much easier to use it in a scripted fashion even.
Absolutely, and I think there's still huge room for improvement there. I think as especially just living day in day out as a developer, I lose sight of what things administrators are now doing with ZFS and ways that they want to use it. So having that feedback is so valuable to us, because it gives us the opportunity to like fix it in a way that helps not only that particular developer, but potentially a much larger community.
Well, yeah, I guess as a developer, you probably deal a lot of times with short-lived data sets, right? You build a data set and then you throw it away and make a new one all the time.
Right.
Whereas, I have ZFS volumes that are 2 years old now, and it's like, they start to act differently than what your new ones probably do.
Yeah.
Sure. Well, I'd say, throwing my 2 cents in here, one feature I really dream about is having a persistent ARC. In other words, I go buy a 40 gigabyte SSD, super cheap, right? Throw it in my desktop and attach it as like a cache device. And knowing that, 40 gigs is going to get cached to the SSD. When I reboot, it's able to pull probably most of the same stuff off the SSD, and it just makes the system fast. For desktop usage, is anything like that possibly in the works?
Actually, that is very close to being complete. So
yay.
in the Lumos community, we actually have one of the developers who has effectively a version out for review right now to do persistent L2 ARC. So it would give you that functionality. So I expect that to, we're going to go through the basis of actually getting it reviewed and tested. And I think some of the distros have already started pulling patches and kind of doing their own testing, which is great. That's the kind of thing that I love to see, is like somebody puts it up on a Lumos and you have somebody from like Linux pull it down and say, sure, I can do some testing with, that patch on even before it's committed to an upstream repo. So yeah, I stay tuned. That's not that far away.
You just made my day. You totally made my day.
That's the L2 ARC. So if anything's really popular, it'll only be in the ARC. So is there a way to say, at shutdown, I want to flush the ARC into the L2 ARC?
So that's definitely an enhancement you could do. You could definitely say, okay, I know that I'm on the verge of actually either exporting that pool or doing, like you said, a shutdown. And at that instance, say, take the most popular items that are in the ARC, or the ones that have had the most recent hits, instead of actually pulling something that we would pull off at the tail end. At that point in time, we could actually flush out more recent blocks so that they would be available. So yeah, I think that's a natural progression for that type of project. It's a great idea.
Cool.
Oh, very cool.
So I guess another question we get often is, do you think we will ever see native encryption, and if so, when?
Wow. So I think really that's going to be one of those things where demand is going to drive innovation, and I've seen this kind of happen in different platforms where people have come up with different ways to encrypt their data set by either inserting kind of like a pseudo driver underneath ZFS or something above it. So PCBSD has experimented with both, right? You had Gedley under ZFS and then switched to PEFS on top of it.
We're doing PEFs on top.
Yeah, so
purely so that snapshots are encrypted when we replicate them.
And I think the reality is, this is going to kind of be, I think this is kind of the meeting of the minds of a couple different communities. Those that are very familiar with the cryptography and all the different security features that you would like to see encryption, and then those that are very intimately aware of ZFS and kind of the internal, workings of it. And to be honest, that's kind of what happened because as I was leaving Oracle, this was one of the last projects that we were working on, and that's exactly what happened. We had, Darren Moffat, who was big in security, working very closely with the ZFS developers to make sure that those two pieces kind of interacted in a very clean and efficient way. And I think that's probably what's going to have to happen is finding somebody who's very interested in and knowledgeable on the cryptography side to work very closely with ZFS developers, either as kind of a cross functional project, or even just providing guidance and mentoring. I had heard a long time ago that there were some people that had taken some of the early released versions that Oracle or Sun had put out of the encryption gate, and were working on that, but I have not seen anything recently about it. I'm more than happy to help mentor anybody. Unfortunately, based on the typical work that I do, we don't have a need for encryption,
Right.
so it hasn't been high on our priority list. But I think if there's anybody out there that is seeing this broadcast and is really, really interested in doing that, I think we would welcome that as a project that could be done, not only with somebody that is, with people that aren't familiar with ZFS, but working very closely with the ZFS developers to actually get it done.
Yeah.
Cool.
I don't mean to really volunteer him, but PJD wrote the Geli encryption layer and ported ZFS to FreeBSD. Seems like he would know both sides of it.
Oh, I'm sure he's not busy.
Right,
at all,
yes, but he's pretty busy. But yeah, and I guess the other part that comes into that is if you're going to be doing encryption in ZFS, you need to build the key management stuff into the administrative framework. Especially one of the ideas behind ZFS encryption, as opposed to just doing it under with Geli or over with PEFs, is having different keys for each data set. And doing things like rotating the keys and a lot of the stuff that was the original idea behind encryption for ZFS is kind of even relies on features of ZFS that never got finished, like block pointer rewriting, where you would be able to change the encryption key by reading the blocks and then writing them again with the different encryption key.
Right, right. And again, I think that's where the OpenZFS community is very vital, because coming up with that administration model that works across all platforms, I think is really the key. Once you determine that, yes, there's somebody that's interested in actually doing the interaction with whatever whatever security feature needs to be enabled on whatever platform, it's really a matter of coming up with a common administration model that's going to work across the board.
Cool. Are there any specific new features that you're personally hacking on at the moment?
Yeah. So I've been spending quite a bit of time on dealing with fragmentation and kind of observability of free space. So you will see there's going to be a new fragmentation metric that will be available to you as an administrator. So not only, when you do something like a zpool list, instead of showing you, including like free space, allocated space, your capacity, you're now going to see a fragmentation metric that'll give you an idea of how that space is really laid out. And the way that we're leveraging that fragmentation information now is to make better decisions on where to allocate from. This kind of goes back to the imbalanced LUN issue, is can we actually be smarter about how we allocate blocks on a pool so that we can take advantage of as much performance as is available. So I've been working on that. Along that, I've also started a prototype of a compressed ARC. So this is the ability to actually effectively double your amount of available RAM by having things compressed. The first prototype that I'm looking at is to actually have this as kind of a stage where most of your ARC would actually be uncompressed, but as you try to go through the eviction process and things that are about to go out to, or about to get paged out, those would get compressed first, just in case you actually happen to hit on it. You would have a quicker access by simply uncompressing it. So we're playing with that. That was actually one of the things that I started working on as the hackathon. Myself and Robert Mustaki from Joyent have kind of teamed up to try to get that as a framework. We think we have kind of the initial framework together, and it's some more work needs to be done to kind of polish it up and make sure that it's at least the prototype is working.
So with that, you just once the ARC got more than so much full, instead of looking at evicting stuff, you start compressing stuff to fit more in there.
Exactly.
Is that the point at which you do that a tunable?
So initially it will be a tunable. I kind of see this as a progression where initially it'll be, as you mentioned, you have so much that's available uncompressed, and then as you get a certain threshold, then you start compressing it. But if our prototype goes well, the idea could actually be that you could have everything compressed in the ARC.
Right.
And especially now with things like LZ4 as a compression algorithm, which is actually very fast to decompress.
Right, you're getting like
you can afford to take
gigabytes a second of decompression per core. So
exactly. So you can afford to take that that negligible CPU hit and get so much more in cache. So hopefully that's, if the prototype works well, then we'll actually look at, probably not making it a tunable. The tunable would just be more of a toggle on-off thing, and then go to a 100% compressed arc. There will always still be some things that we won't compress simply because they'll be like referenced by the DMU or some other component.
Sure.
But yeah, so we're kind of seeing this progression that we think that we can, especially as you start looking at servers that have like, a 512 gig or a terabyte of RAM, being able to get double that would be fantastic. So we think that this could actually be a very interesting kind of game-changing feature. And it would actually tie very nicely, especially with like a persistent L2 arc, because now, we have compressed L2 arc. So having compressed arc blocks already just means that we just simply, avoid compressing them to the arc or to the L2 arc. We just simply, write them out. They're already compressed. So that's one of the things that I'm also working on. And then I think the last thing that I've started some investigation is improving synchronous write semantics and synchronous write performance. That's key to our customer base. And we see that there's probably a lot of room for improvement there. So we're doing some kind of investigation and interesting things that hopefully we'll push out to the community if things go well in a year or so.
Cool.
So how did your developer summit and hackathon go?
It actually was fantastic. We had a slew of probably like 30 plus developers that actually came, and we knew the timing. It turned out the timing wasn't all that great because there was another conference going on in San Francisco at the time, so people had trouble kind of getting hotels and getting in. So we appreciated everybody that was able to make it. Lot of good collaboration. We had some great ideas that are coming out from different companies like, Nexenta, and things that are happening at IX Systems. And I think it was that ability to have all the platforms represented that really made that developer summit so great. A lot of good hackathon ideas. There's one of the, we actually had kind of a hackathon prize and that went to a team that worked on trying to get the test suite on all platforms. So they were actually able to get the test suites now running on Linux and FreeBSD. So they've been doing some testing there and kind of enhancing that. So there's more work to be done, but that was a great push forward, because as we start looking at having a common ZFS and repo, we want to make sure that everybody's able to run the exact same test suite to make sure the functionality and all the regression tests are done in the same way. And then there was an interesting project that's actually being done by some of my colleagues at Telfix, where they're actually looking at getting Lua into the kernel and having a way to actually, it's called ZFS channel programs, but it's a way to have kind of a scripting language where you can insert these simple administrative scripts and push them down to the kernel so that they're done in an atomic and consistent way. So things like recursively taking snapshots today requires us to do a lot of manipulation, because you have to go and traverse the number of snapshots, but you're doing a lot of that without any locks held, so that can actually change. So as you're processing and taking recursive snapshots, a lot of times what happens is things can change under the covers. But by having this new little kind of Lua implementation, it's possible for us to kind of pass a script that says, traverse all the snapshots or traverse every snapshot that's available, snapshot it, but do this with, consistency checks like locks held and so forth. So it'll be interesting to see where that's going. Again, that's kind of like a prototype thing. It was probably one of the more intriguing projects out there, simply because it is introducing this, this scripted language into a kernel, and we'll see how that is received cross-platform. But
Sure.
But yeah, it was a great 2 days. Where right now we're kind of looking at trying to have possibly a 6-month cadence for this, so that we have the ability to kind of stay in touch with the all the different platforms and developers there, and hopefully expand this in the future, even to the point where we can have a developer portion and an administration portion, and in a hackathon, or we'll see how it goes. But I think the early response and the early feedback says it was a big success.
Yeah.
Oh, cool.
So is there anything specific you'd like to see added to ZFS in the future? What's your pet feature? Maybe not one that you would do, but just the thing you would always, your pie in the sky goal.
I have some pet features that aren't necessarily new features, but maybe reworking of some existing features, which I think I've always kind of like wanted to see somebody really just take on and kind of clean up. And one of those is the way we deal with spares and cache devices. Spares in particular because there's, again, interactions that are there for Lumos that are very different in like FreeBSD or Linux. So it would be nice to come up with a common way for us to deal with spares. And from from a developer's perspective, especially somebody who, I work primarily on the lower layers of ZFS, so I see how this has been coded up, and it's always kind of been a bolt-on component, and it would really be nice to see kind of streamline and see this become a true kind of very nicely integrated feature. So I really would love for somebody that kind of wanted to take that on and start playing with it. I would love to kind of help somebody kind of work through that. And another one which has kind of come up more recently is there's a lot of locking structures, and I think this goes towards how ZFS is scaling in the future, especially with like flash devices. I think we have a lot of reworking to do with like lock contention, and so I would like to see some kind of work done there.
Cool.
On a personal note, I would love to see like the Lumos community and the Grub2 community come together to get ZFS boot on Grub2, especially on EFI devices. I think that's an area that's missing. I think somebody has already implemented part of that, but I would love to see somebody really take that on and own it. And I'm sure that
dealing with the same thing on the FreeBSD side, there's work ongoing for the kernel to do UEFI natively, and then we actually use Grub2 for PCBSD, and we can EFI boot off of that. It's just getting into the kernel at that point doesn't work so well.
Well, I guess, an interesting feature there was, I guess Lumos has boot environments, right? Yeah, so implementing those with Grub like Chris did might be really interesting. We scripted out all the Grub scripts which work with the boot environment command, so similar to how Solaris would. So you can choose which boot environment to boot from the Grub bootloader.
Yeah, see, that would be awesome. Yeah, those are kind of, personally, I would love to see that kind of really flourish and get to a very feature-rich completion across all the platforms, because I think that would be, and I know like other platforms are even still struggling with like the installation of ZFS on root.
I had to personally solve that one myself for everybody's benefit. So where can people go to get involved with development, and what are the things you guys are really looking for?
Yeah, so I think anybody that's interested in finding out more, there's a mailing list that you can actually sign up for at open-zfs.org. So that would be the first step, is get involved with, sign up to the mailing list and kind of start, kind of contributing ideas. And I think, beyond that, it's really just spreading the word. It's letting people know what is going on with, with OpenZFS, and that community is really thriving. And we're looking for ideas, So I think feedback, anything that people can provide, the OpenZFS website is a great way to do it. And even if you're not a developer and you're interested in just kind of contributing, you can always create an account on open-zfs.org and, provide documentation or, anything that we're looking for. People that really want to get involved. The community is young right now, but it's growing.
Well, cool. Anything else you'd like to mention as we wrap up here?
Well, first of all, thanks for inviting me to the show.
Thank you for coming.
And I think, for me, I want to personally thank the various communities that have really made ZFS what it is today. It's great to actually see that growing. I don't think that when I got involved with ZFS, back in like 2005, I don't think that anybody kind of envisioned it would be where it is today. So personally, I think that's really can only be attributed to like the system administrators out there, the different platforms who have like kind of taken hold of it, and it's created a great following. So I think that's wonderful, and I just want to thank everybody that uses it and wants to be involved, and I look forward to working with people.
Yeah. I guess, and
cool.
the one other thing is George will be hosting Open ZFS office hours Thursday, December 12th, and you can find out more about that on the open-zfs.org website.
Okay, next up, we're going to be taking a look at our tutorial today, a crash course on ZFS. So originally a proprietary feature of Sun's operating system, ZFS has become the most powerful and flexible file system to date, and completely open source. Open source development has since moved to the OpenZFS project. ZFS is actually not just a file system, it's a complete suite of tools and a volume manager with RAID capabilities. ZFS boasts data integrity features that other file systems just lack entirely. Unless specifically disabled by the administrator, all data written to the disk has a checksum associated with this. Please don't turn this off. By doing this, ZFS is able to detect silent data corruption and provide a level of reliability that is unmatched, basically giving you a heads up, hey, this drive's preparing to fail. This reliability is increased when you couple it with a solid, mature implementation such as FreeBSDs or maybe a Lumos, which also provides a very stable implementation. Work is ongoing to improve Mac OS X's version as well, but it's not quite production ready yet. And as well, ZFS on Linux is still in its infancy, so it should probably be avoided in a production environment, but they're getting there. They're working on it quickly. So let's go ahead and take it away, Alan. Show us how to set up the ZFS here.
Okay, so the first thing I just showed was enabling the ZFS in rc.conf, and basically what that does is during boot, it'll mount all your file systems you create. So anyway, first thing we have to do is create a storage pool. One of the advantages of ZFS is that you combine a bunch of drives into a single storage pool, and then on top of that pool, you make many file systems. And then all of those file systems has access to all of the free space, although you can create quotas and reservations to limit individual ones or make sure certain ones get more space or whatever. But the main advantage over partitioning a regular hard drive is your free space is available to every file system you create. And so you don't run out of free space. There's nothing worse than having one partition with 10 gigs of free space and a second partition with 10 gigs of free space, but you need 15 gigs of free space in one place. And so you have this problem if your free space is fragmented. With ZFS, you don't have that because your free space is all in one pool, and then you draw from that to make whatever you need to make. So normally you create ZFS pools out of whole hard drives or partitions on a drive. A lot of documentation mentions, you should use a whole drive, otherwise there's performance problems. That's not true on FreeBSD. You can use a partition and it'll be just as good as using the whole drive. On Lumos, because of the way Solaris works, using the whole disk is better. And that's why a lot of the original Oracle and Sun documentation says to use a whole disk. But you can also use files. So in this case, we're going to just use some files to simulate having a bunch of disks because it makes it easier to demonstrate and play with it. Right? This will allow you to play with ZFS without having to reformat your hard drive.
Sure.
So I'm going to use the truncate command to just make a bunch of 2 gigabyte files. File 1, 2, 3, and 4. So I've created 4 2 gigabyte files, and now I can create a ZFS pool with those. So I just do zpool, create, then I pick a name for my pool. I'll call it my pool.
That's very magical.
Yeah, well, it's better than tank. I don't know.
What's wrong with tank?
I don't know. It's just a bad example that's been propagated everywhere.
I think I saw Pavel do that back in the day.
Yeah, and it's like all the documentation everywhere uses tank. And it's like, I think some people have just gotten to the point where they think you have to call it that. And it's like, no, call it whatever you want.
It is the tank.
Yeah. I understand calling it just pool would be confusing, but
I'm just going to alias zpool to ztank and just be done with it.
well, all of mine are called zstore, but that's just because that's how I do it. But anyway, the next thing to do is to decide what type of pool you want to create. So in ZFS, you have what are called VDEVs, and those are your virtual devices. And you can create, if you just have each VDEV is one disk, then you could use all 4 disks and you would have striping across those. The problem is there's no redundancy there, right? If one of those disks fails, then basically a quarter of every file you've ever written exists on a drive that doesn't exist anymore, and so all your files are corrupt. So that's generally not what you do. What you can do instead is have one or more pools or one or more VDEVs that consists of a transformation. So with 4 disks, our easiest 2 options would be 2 sets of mirrors. So we'd create 2 mirrors, each of 2 disks. So we'd have 2 VDEVs, and then if one drive fails, the VDEV still works because we have the second mirror. Or you can do RAID Z, which is similar to RAID 5.
Sure.
RAID Z1 means that there's 1 redundant drive, Z2 is 2, and Z3 is 3 redundant drives. So in our example, we use RAID Z1. Okay, so we just do zpool, create my pool, then our type, which can be mirror, RAID Z1, Z2, whatever. For stripe, you actually don't put anything rather than actually putting the word stripe, because you're not doing... If you create multiple, you can also create multiple RAID Z1. So if I had created 8 virtual disks, I could do a Z1 of files 1, 2, 3, and 4, and then just put RAID Z1 file 5, 6, 7, 8, and it would create 2 VDEVs, each one a RAID Z, and stripe across them. And that's why you don't have to provide the keyword for striping, because it automatically stripes across all the VDEVs. In our case, we're just going to create only 1 VDEV. So now if we do ZFS list, we can see we have the my pool, and
Our
it's
tank.
there.
Oh, pool.
By default, it mounts to / the name of your pool, but you can also do during the create -o mount point equals somewhere else and mount it somewhere else. One of the most powerful features of ZFS is the ability to create multiple separate file systems within this common storage pool, and you have different settings on each one. So what we'll do is create a sub data set. So if we just do ZFS create, we'll say my pool /USR. That'll create a new pool. And now when we do the list, you can see we have our 2 pools, or 2 data sets on the 1 pool.
Yep.
And then you can do a sub data set of that, but with an option. So we'll do ZFS create with the -o for option, and we'll set compress equals LZ4 on USR /ports. Now when we look at the list, we see we have our 3 data sets. But if we do ZFS get on those, on my pool, we can see that by default, the my pool data set has compression off, which is the default, and the USR has compression off, which is default. But user ports has compression set to LZ4, and the source is local, meaning we specifically set it to be LZ4 on that data set.
It wasn't inherited.
Right. So now if we create user ports dist files and look at the ZFS get again, we can see that for dist files, the compression is set to LZ4, and that's because it was inherited from its parent, the user ports directory. But we can also just do ZFS set, and we can set compress to off for my pool user ports dist files. Since your dist files in your ports tree are usually already gzipped or whatever, they're already compressed, so you don't need to compress them. So now we can see that on the child data set of ports, we've actually locally set compression back to off. So anything written to user ports will be compressed, but things written to user ports dist files won't be compressed. And that kind of picking and choosing different settings like that really gives you power to do a lot of different things. For example, if you're doing an SQL database, they recommend you use a 4 kilobyte block size for your actual database, but the log files probably want the full 128. So if your log files are in a subdirectory, you can have different settings for each directory that way.
Well, what I love about this is most of this you're doing is post-installation. Yes. If you installed, say, ZFS on root, I don't have to worry, okay, I'm going to do this install, and I'm going to need all these data sets this way, and then find out a week later that's not right. Like, oh, okay, no big deal. I'll just deploy a new data set, set some options, done. Like, I don't have to worry about resetting up my box.
Right. For one caveat there is with the compression and things like that. When you enable LZ4 compression, only things written after you turn it on are compressed. Yeah. Or if I turn it off, everything I wrote before is still compressed. If I overwrite that data, it'll be written uncompressed.
I'm thinking more like I don't have to go repartition my disk now and go, oops, I forgot to make that data set. Let me go repartition my drive, and I can't do that. Yeah.
Right. It just allows you to make as many data sets as you need, and you don't have to decide how you're going to allocate that space. You have all your space, and you just create as many different data sets as you need.
Yep.
And then, at the end, we can do, say, ZFS destroy on my pool user ports dist files, and now that's gone. So all the data was there is destroyed, and we get all that free space back. And that space is available to all the other data sets now. So it's great for temporary stuff too. You can say, put this over here, I can play with it, and when I'm done, I can just throw it away. Or you can do zpool destroy and get rid of an entire pool. We're not going to do that because we need the pool to finish the tutorial. So one of the other main features that everybody loves about ZFS is snapshots and clones. So with a snapshot, you're basically taking a point-in-time copy of the file system. So saying, all right, right now I'm going to create a snapshot, and that's how the file system existed at this point. And then I can go and change it, and anything that gets overwritten, we save the original version as well. Right? Because ZFS is copy on write. Every time you overwrite something, it doesn't actually overwrite it. It writes the new data to a new place and then updates the references to point to the new place. And then that old block just becomes free space. But if you have a snapshot, that old block is still being used. So it doesn't actually become free space. And you keep it so that you can always go back to what it was before, which is great when you're doing upgrades or working on different things. So to show you how that works, we're going to create a file. So we'll just use dd quick to read dev random and user ports and create our test file. And we'll create a 10 megabyte file full of random data. Because we're using files, it's a little slow. But we can see now we have a 10 megabyte test file. So what we can do now is if we do ZFS snapshot, and we can create a snapshot of my pool /usr/ports, and we'll call this the first snapshot. Actually, first time we're going to recreate that data set we destroyed because it's part of the example here. Oops. Anyway, so now we're going to create the snapshot. We'll call it our first snapshot since it's our first snapshot. And now if we do ZFS list and we set the type to all, so it'll show main data sets and snapshots. And I'm just going to set a specific list of columns to show to make it shorter. So anyway, we can see we have our user, or my pool user and ports, but we see ports and the all children of it, because we did -r to make it recursive, have snapshots. So we can see the ports directory has 10 megabytes of used space and is referencing 10 megabytes of space. The snapshot is actually using 0 bytes, but it refers to 10 megabytes of space because it contains a complete copy of that 10 megabyte file. But that copy isn't using up any space because it's identical to the original.
Well, it's not necessarily a new copy on
Right.
the disk. It's just a pointer to that.
It's just
saying, don't change
right. It's
this.
a reference to the original 10 megabytes. So now what happens if we go and make a change to that? So I'm going to do another dd command, and what this one will do is we're going to seek 5 megabytes into the file and then write 10 more megabytes. So we have the original 10 megabyte file, and we're going to start halfway through that. So we'll overwrite 5 megabytes of data and write 5 new megabytes of data. And then if we do that ZFS list command again, what we'll see is how ZFS accounts for those different amounts of data. So we see in the user ports, the give it a second to finish writing. There we
Are
go.
you doing this with ZFS on top of
Yes.
ZFS?
This is ZFS on top of files that are on top of ZFS, hence why it's
Oh, nice.
on a really slow old 300 gig hard drive in a machine in my basement. So that's why it's not performing as well as it normally does. So anyway, in the ports data set, we see we're now using 20 megabytes of space, but this data set is only actively referring to 15 megabytes because the file that we've written is only 15 megabytes. And we see that the written property only counts for 10 megabytes. And then the snapshot is using 5 megabytes because it's the 5 megabytes that were overwritten. We saved those 5 megabytes and refers still to the whole 10 megabytes, 5 of new data and 5 of the old data. So now when we look at that file, we see that the test file is actually 15 megabytes.
Yep. But wait, there's more.
So now we can also look in ZFS. There's a hidden directory called .zfs. So if we look under my pool user ports .zfs, there's a subdirectory in there called snapshots, and then there's one subdirectory for each snapshot you've ever created. And if you look in there, you can see what is in the snapshot, right? So a snapshot is basically a read-only copy of the file system from the second you took the snapshot. So in the snapshot, that test file is still only the original 10 megabytes. And so say we didn't mean to overwrite the middle of that file. We can decide to roll it back, right? So if we just do ZFS rollback, my pool user ports at first snapshot. Now when we look in this directory, we see that the test file is back to being just 10 megabytes. And when we do our ZFS list, we see that the used space is back to just 10 megabytes, and the snapshot isn't using any space. That's 1.5 kilobytes of metadata, but the data set's back to just being 10 megabytes because we undid all the changes we've made in the last couple minutes.
Well, as an aside, you don't have to revert that either. This is actually how our new life preserver utility works on PCBSD. It's basically just doing these ZFS snapshots in the background. But that's where we do like a time slider like functionality where you can roll back a directory and go, oh, here's my document from 3 weeks ago. I can copy that back, without overwriting my new document, which maybe has new data in it that I want to keep.
Right. That hidden .zfs directory we looked at, you can just copy the files from there back. But if you wanted to do everything, if you copied everything back, it would waste a bunch of space because you would overwrite it and so on. So yeah, the rollback is not something you use all that often. And usually you'd only use it based on a snapshot you took very recently because you don't want to lose everything you've written since then. You just want to recover 1 or 2 files.
Yeah, a lot of times you're after one particular target, like, oops, I didn't mean to delete that file.
And that's where that hidden .zfs directory comes in really handy. The other thing you can do is you can create what's called a clone. So snapshots are read-only because you can't write, but a clone basically makes an entirely new data set based on the snapshot. So that snapshot basically shows up when you clone it, it shows up as a new directory, and it contains all the same files, and then you can write to it and make changes, and it's completely separate now. If you get your directory just right, you can clone that a bunch of times and then try different things in each one and see which one you like, and then keep that one in the end and delete the other ones. And things like that.
And that would be how we do, like, say, jails on FreeBSD. We create our base jail and, like, okay, now I'm ready to deploy this 10 times and then customize them.
and you just mentioned your life preserver utility. One of the other really cool features of ZFS is send and receive. So you can actually send the contents of a data set. So we can do ZFS send, and we'll just do the mypool/user ports at first snapshot. And we can send that off either to the same machine. We could do a pipe it to ZFS receive and just, copy it to a different data set or a different pool on the same machine, because I actually have 2 pools on this machine. Or you could use something like SSH, and we can run ZFS receive on a remote system. Media/tutorial.
So while you're typing out, that's also what the life preserver does.
Yep.
When it creates these snapshots, then you can point it at a remote box, say a FreeNAS or some other system with ZFS, and say, okay, I'd like to back up my desktop or files or server to that system. And it's just doing the send and receive commands in the background.
Yep. And so that'll actually allow you to back up your files to a remote system. And it's very useful. And if you're using the ZFS allow system of permission delegation, you can even set it up so it doesn't require root to be able to do it. And there's more about that in the written version of the tutorial. The written version of this week's tutorial has about twice as much stuff as we have time to show today.
Sure.
So one of the other interesting things about ZFS we mentioned was the checksums. Every time you write data, it calculates the checksum and writes that in with the metadata. And then when it reads the file back, it calculates the checksum of the data it read and compares it to the one the checksum from when the data was written. And if they don't match, it knows that the disk corrupted something at some point. And if you have redundancy, it will try to recover. And that works great, except for what about files that you wrote and then you never read? You don't detect when they have corruption until the minute you need them, which isn't great. So ZFS has this scrub command. So if we do zpool scrub mypool and then run zpool status, we can see that it will actually read the data off all of the disks and checksum them and see that, it managed to do all that. And so it'll read every block and check the checksum even if the file's not being used. So, if you're using a FreeNAS, I think they have this set up to run automatically once a month.
Every 30 days, yeah.
And, that way you can find out if something's gone wrong. So, in this case, we'll actually simulate something going wrong. We're just going to...
oh, noes.
We'll just delete disk number 3 out of our pool.
Oh, no.
Right? So now when we do a scrub... So now we can see that our pool is degraded because one or more devices is taken offline or is missing because the drive went bad or whatever. But sufficient replicas exist for the pool to continue functioning in a degraded state. So it might be a little slower, but all your data is still accessible. And this is the advantage of using RAID Z as opposed to just striping all your disks together and not having any redundancy.
In my case, I'm using mirroring on my build servers, but I've had that same pool running for years now. And I think just about every disk in there has failed at one point and been replaced. And it just keeps on trucking.
Right. So here we go. We see that offlining it and onlining it made it realize the file's missing now. So we see that one or more devices cannot be opened because it's gone or whatever. So we can see that we have the random ID for the disk, and we see that originally this was our file 3. So now I can just create a new file 3, which is empty, and then do the zpool replace command. So in my pool, we want to replace that random ID with the newly created file. And now when we run zpool status on my pool, we'll see it resilvering. What it's going to do is look at all the data that should be on that missing disk and write it out to that disk. And you see right now it's in the process of replacing the old disk, which is unavailable, with the new disk. And it's currently in the resilvering process. We can see it's scanned 14 megabytes out of 14.6 megabytes at 3.5 megabytes a second. And that it's 95.85% done.
Blistering.
So now that it's done, we can see that the pool is back to an online state, and it managed to recover the 3.51 megabytes of data that should be in file 3 but was missing. And it did that in 0 minutes.
Nice.
And so now...
Somebody in the chat earlier had asked about how you'd add additional drives.
Okay, no, but if you want to add additional storage,
similar command.
If it's a single drive or a mirror, you can use the attach command to add more disks to the existing VDEV, but that won't give you more space in the case of a mirror. With RAID Z, you can't add more disks to that RAID Z, but you can add a second RAID Z. So if I just do that quickly with the truncate command again, and we'll create files 5, 6, 7, and 8. I can do zpool add to my pool a RAID Z1 array that consists of file 5, 6, 7, 8.
And magically we have more space.
Yep. And then when I do a zpool status, we'll see that now our pool, my pool, consists of 2 separate RAID Zs. And then if we do our ZFS list, we see the amount of available space has ballooned up to 12 gigs from the original 6 gigs. Because now we have these 2 separate, one single redundancy arrays. And that's all it takes to add more space. And because the one set of drives is more free space than the other, oops.
See, I told you guys it was almost, pretty much a one-liner there. Look at that.
Why does it not want to do what I want it to do? There it goes. You can see now that the first RAID Z1 has 13.9 megabytes allocated, and the second one has only 30 kilobytes. So the second one is a little bit more full. ZFS will try to balance the writes so that both of these arrays will get full at the same time. So it'll write a little bit more to the newer one. Now, what George was talking about in his interview with unbalanced LUNs is if you don't add this second one until this first one is like 80% full, then a lot more is going to be written to this second one. And when you're reading it back, you're not going to get the performance of 2 whole sets. You're going to get mostly performance of just the one. And he's been working on a bunch of changes that will make it a little bit more intelligent about that and trying to deal with the fragmentation and get even more performance out of this.
I'd almost like a defrag command, something like a scrub where I could say, okay, go ahead and balance these now.
That was called block pointer rewriting, and it's basically like a magical unicorn that will solve every problem.
Right.
But as Matt Aarons likes to put it, it's also like trying to change your pants while running.
Well, yeah, true.
But, if you were used to having the performance of one RAID Z pool, and then you ran it was full and you added a second one, you're still going to get the same performance, right? You're going to get the performance of one RAID Z pool, or maybe actually slightly more. So it's not a big deal, but it could be even better, and that's some of the stuff that George was working on.
Sure.
And we thank him for that. And so the one other thing that we kind of touched on was the idea of boot environments. So the idea here is when you're using root on ZFS, so your whole operating system is installed on top of ZFS, so your slash partition and the things like your kernel and the user lane and all are installed on ZFS. So you can make a clone or a snapshot of that data set. So if you're going to do an upgrade, you can clone the system first so that in the event that the upgrade goes bad, you can decide to boot up that clone instead. And that'll basically allow you to go back to how your system was before.
Sure.
And that's all built in automatically if you're using PCBSD.
Yay. Yeah, that was a cool feature we put in 9.2, and that's a game changer, man. If you can instantly create a backup of your system and say, okay, that didn't work, and we roll back to yesterday or last week, just at the boot prompt.
So yeah, we can see here, if we do the badmin command and we create a new boot environment called sumupdate, and then we do badmin list, we see that we have 2 boot environments. The one called default, which is currently the one that's active and mounted, and it's mounted as slash. And then we have sumupdate, which is our backup copy. And then you can choose to either switch to that one and then do the update, or to do the update on your default one, and if it doesn't work, switch to the one that's a snapshot from before the update. Or the badmin script also has the ability to allow you to even do crazy things like mount that new snapshot called some update in a jail. And then you do the update in the jail. And then you can check it and make sure it works and then reboot off of it.
Yep.
It's very handy. And you can switch between these by just doing badmin activate and some update. And now
That's a feature we want to use at some point, not so much for checking it in the jail, but being able to do the update while you're working on the system.
Exactly.
And then when you're ready, you just reboot and boot right into the updated system.
Yeah, so you're not, you don't want to stop using the system while you're doing the update. I guess the only issue with that, depending how you separate it, any changes you make between when you make the snapshot to do the update in and when you actually reboot. So if you're running off the default data set and you make a snapshot and you're installing the update and it takes half an hour, anything you changed in the default data set in that half hour is going to be undone when you switch data sets.
Well, not in our case, because most of your stuff's going to be going in user
which is a completely
home,
separate data set. So
separate data set. So it would it only would affect user local, which is where packages
and
live.
on my badmin setups, I have that completely separate, so it survives between all my boot environments.
See.
I'm more worried. I want my packages to work everywhere, whereas you want to have. You want to be able to roll back your packages as well. Where I'm
because I'm thinking of like when we upgrade KDE and it goes sideways. Like, I'll just roll back to the last boot environment, which has a good KDE.
Right. Whereas I'm like, I can manage that manually. Whereas you don't want users to have to do that. Mine was more, I have these 9 packages and I want to be able to use them on my 10 boot environment, which is obviously not a regular use case. Anyway, because I did the badmin activate, you can see that now the some update one is the one that's active, and when I reboot, it's going to boot off that one instead. And then any changes I make now would be undone. And you can see how that could be very handy. And I can also just go back to activating the default, and now it's going to boot off the default instead. So that little badmin script is a very handy bit of shell script. And I guess there's one more thing we're going to show. We looked at the compression stuff. If we look at the oops, compress. ZFS also gives you a bunch of really interesting stats. If we do get all pull user ports. If we look at all of the properties, you can see quite a few different properties. The type, whether it's a file system or a volume, when it was created, how much space is used, how much is available, how much is referenced. But you can also get things like the compression ratio, which should be higher, I think, actually. We'll look at that in a second. Whether it's mounted, if it has quotas, record size, mount point, compression is turned on, we see, and all the cool stuff. Oh, right, we rolled it back, so it doesn't have all the changes. All right. Okay, so now if we were to copy something like... we'll copy a copy of ETC over onto this data set. Now when we do... now we can see that the compression ratio is higher because we actually we copied some files that were compressed. So you can actually, when you have compression turned on, you can tell how much space is actually saving you. Right, so we can see that logically there's 11.2 megabytes of data written, but the actual amount of space used is only 10.09 because we actually have some compression going on there, right? And so we've actually gained some compression. And you can keep track of that using these different properties. And it even gives you properties like how much space on this data set is used by snapshots and versus what's used by data sets and by children and references. And you can see all the different settings you can make. And then if you read the text version of our tutorial, we even get into how to do deduplication. So if you're writing the same file twice, if you're using your ZFS pool to store backups of 10 machines, well, if all 10 machines have a couple files that are the same on every machine, why waste the space? With deduplication, you can say, hey, these blocks are the same. I'm only going to write it once and then reference it. Although it requires a lot of RAM to do that because it has to store this list of every SSH56 hash of a file and where it is on disk, right? And, you've seen SSH56 hashes. They're like this long, right? So that's a lot to store in memory. But if you have the memory, it can save you a lot of disk space. The tutorial also touches on the ARC, L2 ARC, and ZIL, which are ARC is in RAM, but L2 ARC and ZIL are when you use SSDs to make your ZFS even faster for read and write cache and things like that. So the text version of the tutorial covers all of that. Even talks a little bit about doing spares and all the other stuff that you might want to know about ZFS. And it's all in the written version of the tutorial on our website.
Well, very cool, Alan. That's a fantastic tutorial. I know people have been asking for a ZFS one for quite a while.
And, when we had George on, it was like, that's the perfect time to do ZFS tutorial.
Yeah, we can't not do it then. So hope you guys enjoyed the tutorial. Of course, the notes will be up online shortly after this airs. And next up, we'll be going to our weekly news roundup. Next up, our weekly news roundup. We'll quickly go through some of the notables from this past week. So first up, we have some new information about RUBSD 2013. So that's going to be a conference in Russia, in Moscow.
Next week, I guess.
Yeah, December 14th. So we didn't have a lot of time or heads up for you guys. But if anybody's watching us in the area can get to that, it sounds like they'll have 3 OpenBSD developers there. We have Theodor Rapp.
He's giving his talk, The Bane of Backwards Compatibility.
Oh, nice. And then Henning Brouwer will be there as well.
Yeah. He's talking about PF, obviously. He's a design, implementation, and future.
Yep. And then Mike, I'm not sure how to pronounce the last name, Belopov,
something like that. I don't know.
I mangled that, I'm sure.
Something Russian sounding.
Anyway, so yes. So we'll have 3 OpenBSD guys out there. Let's see.
And it's being held at
it's
being held at Yandex, which is a big Russian company.
Okay, very cool. So we don't know yet if they're going to have any video recordings, but of course, if we find some floating around, we will let you know and provide links to that. What we got next?
Dragonfly has posted their roadmap to the next version. John Marino, who's the guy that ported the FreeBSD port system over to Dragonfly, and he's got his idea of what the roadmap should be. And now that they've gotten past their 3.6 release, the thread went on some of the ways that different crazy ideas people have had, and several suggested items that have already been tackled, updates to the Intel wireless drivers, and changes to BMake, and importing John's vendor branch with updated instructions, and a bunch of other interesting things. But if you're interested in Dragonfly BSD and where that might be going, or maybe even having your input considered on the roadmap, that looks like an interesting thread to jump in on.
Cool. Okay. In addition, we have some information about upcoming conference BSD CAN, of course, one of the biggest and original ones here in North America. So it's going to be held on May 16th and 17th in Ottawa, Canada. Usually it's preceded by a couple days of tutorials and a FreeBSD developer
that'll be the 14th and 15th.
So if you can get out for that, that's fantastic. It's an invite thing. So if you know a committer, you could possibly get a guest invite. But right now they're accepting proposals for talks.
Yes.
So of course I got to send mine in, get something written up.
And if your talk doesn't really have to be about BSD, just something that the people that are going to be at the conference would be interested in.
Definitely send it in. It's just a great conference, good one. Dan Langiel runs it and does a good job with it every year. So looking forward to that next year, and get my talk in here shortly. Are you doing one, Al?
I have to think of something to write about, but then I will submit one as well.
Very cool. You're up in Canada. There's no excuse for
I'm definitely going to go. It's just if I have to give a talk, I have to think of something to talk about.
You got to write something. So, of course, if you're doing anything interesting with the BSD operating system, send a proposal. We'll be trying to do a lot of interviews there. So if you're a developer or doing something interesting, you want us to interview you, come chase us down, or we may chase you down.
We will hunt you down.
Yes, we will. Take you to a dark corner and beat the interview out of you. But anyway, look forward to having you guys there.
But if you're going to submit something, get on it. The deadline is January 19th, and you will find out before February 19th if you'll be expected to show up in Ottawa in April.
Cool.
And also,
That's the next
if
thing,
your
Alan.
company wants to sponsor the conference, you can get information
yes.
on that on the BSD CAN website as well.
And we'll have the link to that in the
Yep.
show notes with the link to the announcement as
Yep.
well.
So next up is a really interesting development. What's it called here? Casper D, which is part of the Capsicum system. The Casper D and the services it provides are responsible for giving access to functionality that is not available in capability mode sandbox. So if something is inside of a Capsicum sandbox, it can go and talk to Casper D to get access to certain things it needs in order to do its work without that it's not allowed to do because it's already gave up those capabilities. Some of the most popular ones are system.dns, providing access to do DNS lookups, and also system.grp and pwd to look up usernames and groups and stuff to see, here's a UID, what user does that belong to, or access to obtain entropy from dev random, and access to different sysctls.
Oh, that's very cool.
So this is a way to further sandbox applications and not let them do anything that they're not specifically allowed to do.
Okay, and lastly, we have a kind of a heads up for anybody running FreeBSD current. There was a ZFS corruption bug
That we told you about
that
last
got
week.
committed last week, yeah, and the fix is now in. So you are safe to resume updating build world and kernel, and hopefully you're in good shape going forward.
Like we said, this was committed like 6.5 days ago, so it was almost right after we finished broadcasting about it, I think. That we said the fix was coming, and it's in there. It turns out,
it did.
Because of a slight difference in the way things are implemented between Illumos and FreeBSD, the offset was just set to 0, because that doesn't actually matter on Illumos, but on FreeBSD, because the way trim works, it uses that offset to know where to trim. And so because it was set to 0, it would just keep, every time it wanted to trim data, it would just trim that much data off the beginning of your drive. So it would just keep erasing the front of your SSD over and over again.
Ouch.
Yeah, which is maybe where your boot sector is, and it's probably not what you wanted it to do. But that's since been fixed and tested and is now available for those of you using current. And that brings in all the changes that the original patch brought in are now free for everybody to use. And that should be quite good.
Okay. Excellent. Well, that's the weekly wrap up for the quick news items. Next up, feedback and questions from you in the audience.
So our first question comes in from some guy named Chris. Not you, obviously, but somebody else. He says he feels bad for adding to our pile of ZFS questions. Between this show and the other sysadmin podcast I do, TechSnap, I must be sick to death of them. But actually, I'm not. ZFS questions are always interesting. So he says he has 6 drives of a given size to include in a pool. Is it better to do 2 VDEVs, each with 3 drives in RAID Z1, or do 1 VDEV with all 6 drives in RAID Z2? Depends what you're after. Performance-wise, the 2 VDEVs will be faster. Or actually, if you want fastest, you would divide those 6 disks into 3 mirrors and stripe across all 3 of those, and that'll give you the most IOPS, but you'll only get 3 times the smallest drive of space. If you do 2 Z1s, each of 3 disks, then you'll get 4 times the smallest disk. And if you do the 1 VDEV with 6 drives and a Z2, you again will only get 4 times the smallest size of the disk. The advantage of the Z2, because it's going to be a little bit slower than the 2 Z1s, the advantage though is any 2 disks failing and you're okay. With the 2 separate pools of Z1, if 2 disks in the same pool or the same VDEV die, then all your data is gone. Now, the chance of 2 disks dying before you can get one of them replaced is not that high, but depending how important the data is, you might decide that that little bit of extra performance isn't worth that little bit of extra risk.
Sure.
But if you're really after the best performance, then you would use the mirrors. And in that case, it's more expensive because you have to buy more drives to get the same amount of free space, but you're getting that much more performance. And you can actually... Mirrors aren't limited to being 2 disks. You can make a mirror that's 4 disks deep. And you can obviously withstand a lot more failure that way, but it also means when you're reading, you can be reading from 4 disks. Now, your writes are still going to be limited by the fact that all 4 disks have to finish writing in each of your mirrors. But for reading back, your read speeds will be astronomical that way.
That's how my home file server is set up. It's a 3-disk mirror.
Right.
And writing's nothing special, but when you go read or stream a video or something off it, it's quick.
So, if your workload is read mostly, then mirrors will definitely provide you the best stuff. But in general, more VDEVs is better, but it's more expensive, especially if you want to maintain the higher resiliency. So,
Sure.
If you wanted the performance and the resiliency, then I would do 2 VDEVs of RAID Z2. But again, in that case, you need more disks, which costs more money. So it's up to you to move that slider between the cost, the risk, and the performance. And you can pick any 2, basically.
Well, I hope you answered your question. Next up, we got a question from SW. First of all, a little bit of feedback. He was wondering if we were going to ask Michael W. Lucas about a 3rd edition at Absolute FreeBSD.
Have we meant to do that?
Yeah, we didn't get to it, but I hope he does one. Not sure what the plan is with that yet. But on to his technical question. He's been running a FreeBSD server at home now for almost 5 years, and just over a year ago, he moved it to ZFS. The one thing he's battling with understanding is the term data sets in ZFS. Maybe Alan can explain it so I can understand the term.
Data set is kind of just a generic term that covers any set in data in ZFS. So a data set can be a file system, which is what it is most times. It can also be a snapshot is technically a data set, a clone is technically, and then you have your volumes. But the main 2 types of data sets are file systems and volumes. So a file system is a directory that's mounted and you can add files to it. And a volume is a virtual block device that you can use you can format it with UFS and run some other file system on it, or you can use it as the disk for a virtual machine or whatever else you want to do with it. Or, export it with iSCSI and use it for a virtual machine or the disk in a Windows computer or whatever you want to use it for. And so, a data set is kind of like a partition, except you don't have to limit how big it can be. With a volume you do, but with a regular file system, it just takes the space as it needs it out of the pool. And whereas with a partition, you say you have this much space, and it's hard to...
Changing it later is a pain in the butt. So he asks also, how does one create a script that creates, say, daily incremental backups from zroot to the backups pool? Well, you could, of course, write that and use ZFS send and receive, or use a utility for that.
So first thing you need to do for that is snapshots. The tool I use is in this sysutils part of the ports tree, and it's called ZFS-snapshot-MGMT for management. And it does automatic grandfathering. So it'll take a snapshot every 15 minutes and then only keep the ones from the top of the hour for more after the first 4 hours. So it has one from every 15 minutes for 4 hours. Then after that, it only keeps the ones from the top of the hour. And then after a day, it only keeps the ones from midnight and noon. And then after a week, it only keeps one each day. And then after a month, it deletes them. Right? So you get this kind of grip. And then the second script I use is called ZXFer. So ZXFER. It's also in the sysutils part of the ports tree. And it will manage replicating. It does the ZFS send and receive for you. But what it'll do is it'll look at the list of snapshots on the source and the list of snapshots on the destination and be like, oh, you already have the first 10 snapshots copied, so I only need to copy the remaining ones. And, we've expired these snapshots over here, so I can delete those. So it'll take care of all the replication for you. And it has built-in support for doing it over SSH and stuff, and it's quite good. And I recently wrote a patch for it that adds the ability to make it draw a progress bar for you, which is very helpful.
Nice. Let's see. He also asked, do you need to keep the original full backup snapshot for all incremental snapshots to work?
No.
When can the full snapshot be deleted?
There's no difference between a full and an incremental snapshot. The snapshots all reference all of the data. So if you delete the older snapshot, the newer snapshot that only contained the difference will now when the old snapshot stops using that space, the new one will not let go of it. So where the space shows up as being used will change, but the disk, it was always used by all of the snapshots.
Sure.
And so that's the nice thing with ZFS is you only need one snapshot, but that snapshot when you delete the full snapshot, you won't get back as much free space as you thought, because you'll only get rid of any data that was in the full, but then was replaced in the next incremental. So you won't save that much space when you delete the full, because it's actually keeping all the blocks that are still in use by one or more snapshots.
Sure. He's also looking for the ability to be able to restore files from the backup pool should something delete from the Z pool root. Have it all automated so snapshots don't fill up the pools, etc. So it sounds like those scripts you were talking about.
And then what we talked about in the tutorial with using the .zfs directory to be able to access one file from a snapshot instead of having to restore the entire backup.
Yeah.
And if the backup pool you're backing up to is a separate set of disks or a separate machine, it's easy to just grab one file off of it. And because you can access those snapshots, you can say, I want this file, or I want this file from yesterday, or I want this file from 5 days ago or 10 days ago, just by going through your snapshots and picking out the version of the file you want. Because the problem with a backup that's just one copy, like if you just rsynching it to a second machine or something, is that if a file gets corrupted and you don't notice for 3 days, now your main and your backup are both wrong. With the snapshots, you can say, I want to go back to 4 days ago and get what the file looked like then. And then is when it saves your bacon.
Yeah. Okay. Well,
so the next question is from
the total of his questions.
The next question is from Jason. He says he's enjoying the show. Keep up the great work. He said I mentioned Geli on top of ZFS. Actually, I meant underneath ZFS, not on top. A few episodes back, and that encrypted data when you do send and receive, it's not actually encrypted because Geli is underneath ZFS. Yeah. And that's why Chris recommends PEFS, which goes on top of ZFS. So when you're sending and receiving, it's still encrypted.
He's asking if you always turn off compression on the Z pool for Geli or for performance.
I wouldn't say so. If you're using Geli, you probably have hardware encryption offloading, which helps a lot with the speed. And so the speed of doing a bit of compression isn't going to hurt much.
Sure. Let's see.
Oh, and he asked, lastly, he read about best practices about using the whole disk. As we mentioned, on FreeBSD, there's no performance penalty for using a partition instead of the whole disk. So on mine, I always partition the disks and do even just like a gig of swap or something on the front of the disk or the end, so that if in the future I'm replacing that drive because it failed, if the new drive happens to be a couple sectors smaller or something, I can take that out of that swap partition and the usable size of the disk doesn't change. And that way, if I'm mixing and matching brands of disks, somebody's 3 terabyte drive,
few bits off.
Yeah, a Seagate 3 terabyte drive is never exactly the same size as a Western Digital 3 terabyte drive. And this way, I always have that wiggle room. So it's perfectly okay on FreeBSD to do it with partitions. On a Lumos, if you're using a partition, it doesn't use the write cache and makes it really slow. Okay. And so that's why they, in their documentation, always recommend using the whole disk.
Okay, next up, we have a question from Clint asking about IPMI. First, he absolutely loves the show. It's by far his favorite tech podcast, so thank you very much, Clint. He can't get enough, though. Wish it was daily. Oh, man, I'm not sure if we'd ever get anything else done, though. we have other jobs, too. So appreciates the effort and great work we're doing for the BSD community. So, Alan, I guess on BSD Talk, you mentioned that you use IPMI for managing your servers. He's very intrigued by this. A few years ago, he was running 9 IBM X Series 1Us, all with service processors. He had physical access to the consoles on those servers, and so he never messed with the management systems. He's interested to hear how you use these systems in your day-to-day, their disadvantages in certain environments, remote and local, terminology surrounding IPMI, standards, protocols, available open source IPMI software, bootstrapping, how the OS and out-of-band management systems communicate. Man, we almost need to have like a segment on this at some point, I guess. So might be too much to answer.
The biggest advantage with IPMI and the way we use it is you can connect to the machine even if it's powered off. As long as if it's plugged into the wall and has power, then the BMC chip is powered up, even if the physical machine is powered off. And you can do things like reset the power. Either do a reset or a hard power cycle, which is very useful on a server that's far away, instead of having to call the co-location and have someone walk over and reboot it for you. But the biggest advantage by far is the IP KVM. the ability to see the console and interact with it right at like a hardware level, so you can even go into the BIOS.
Okay, next up, we have a question from Clint. First up, he says he loves our show. It's his favorite tech podcast. He can't get enough and wishes it was daily, which we appreciate that, Clint, but we do have other jobs and work to get done on the side.
Once a week is hard enough.
Yeah, I think we may have to stick with weekly for the moment. So he mentions that he heard you, Alan, on BSD talk about some IPMI stuff you did on your servers, and he was pretty intrigued by this. Basically, what his questions are is he wants to know how you use these systems in your day-to-day, their disadvantages in a certain environment, remote versus local, the terminology surrounding IPMI standards, protocols, available open source IPMI software, the initial bootstrapping, etc., and how the OS and out-of-band management systems communicate. So it sounds like he almost wants an entire IPMI segment.
Don't have time for that right now, but in general, the main advantage of IPMI is full out-of-band access to the server. You can power the server on and off and reset it, which is handy instead of having to have someone do that at the co-location, especially for me when that co-location is in Rotterdam, the Netherlands, and they're asleep when I'm working on stuff, or and things like that. But also the ability to get full hardware access to the keyboard, video, and mouse. So it does IP KVM. So basically in a slightly modified VNC viewer, I see what was on the console and can interact with it, even so far as going into the BIOS and changing settings. So it doesn't rely on the operating system or anything that's happening on the computer to allow me to do that. Right, it's kind of like Intel vPro, which is kind of a newer take on the same idea. But it allows me to go into the BIOS, make changes or whatever. And one of the newer features that's really handy is virtual media. I can mount an ISO file that's sitting on my hard drive here in Canada on the server in Rotterdam and boot off of it. And this allows me to install FreeBSD and do my custom install that does root on ZFS and all that without having to, the old-fashioned way would be I'd have to make an ISO that did this, upload it, have the people at the data center download it, then they would have to burn it to a DVD and then mount it in the system and try to do it all. And, at some of these data centers, they know a bit about Linux, but they're not going to be able to install FreeBSD for me that easily, right? And especially when I'm doing rather complicated BSD install, right? And so having full access to everything is great. The disadvantages are it's slow. Especially booting that CD takes like 10 minutes because of the way it's reading the CD. The other disadvantage is there's a lot of security issues. So we're lucky most of our providers lock it away on a VPN, and so we have to VPN in to get access to this. But even then, technically if one of them got hacked, then they would have access to try to hit the others and so on. So it's a bit of a trade-off, but the VPN is good enough. It's locked down so that, our VPN user can access our IPMIs, but a different VPN user can access ours as well. And we have to keep on top of updating the firmware on those because there's, known exploits and so
security vulnerabilities.
So, it adds an entire different set of security problems. But the flexibility it gives us and the ability that for me to single-handedly manage all those machines in foreign countries is worth it to us. One of the biggest things we did was in all of our installs, we've modified it so that single user mode on the console still requires the root password. So if someone does manage to get IPMI access, it doesn't mean that they can compromise the machine.
Sure. Well, I think, Clint, hopefully we can do like a little segment at some point, or a tutorial even, on how Alan does his
I don't know much
setup,
about the Open IPMI project, but we do use the IPMI tool to be able to interface with IPMI from the operating system that's running on the machine or from another one. We use that in Nagios, actually, to monitor the power supplies. So Nagios will alert us if one of the power supplies on our machine goes out. Okay, and we had the last question is from yet another guy named Chris. It's a very popular name.
A lot of us around there.
So he says, "Hi guys, after watching episode 11, I've been trying to figure out how I would replace our aging Cisco ASA 5510 that's been our firewall and router. We're only forwarding a few ports, doing a bit of NAT, sending traffic to a DMZ, and all of which I saw how to do in the great tutorial we did. The biggest chunk of usage for the ASA is also our VPN connector. We have 8 site-to-site tunnels to our different sub-offices and an average of 50 Windows laptops running the Cisco VPN client. And the other offices have either Sonic Walls or ASA 5505 appliances that are being used. He's asking, is there a package that would provide that kind of functionality? I don't know. For mine, I've used OpenVPN, but that's a little less user-friendly than something like the Sonic Wall VPN client. I don't know off the top of my head. Is there something like that?
Yeah, I don't know of any either.
And well, if the Cisco VPN client is just IPsec, then I suppose setting up IPsec on the router box would solve it. Short answer is I don't know. He says they're also using Cisco clientless SSL to create a web VPN session to a Windows server in a browser from some of our mobile workers. Is that functionality available? I don't know if that's available either.
No.
Yeah. Sorry.
Yeah, sorry. We'll have to look into that a little better and see.
But if you're somebody watching the show and you know the answers to these questions, please write us in and we will read them out next week. And then people will be able to have the answers.
Yeah. Right.
We don't have all the answers, but we know a lot of people who might.
Yeah, we're good at digging them up. Like, we will find somebody to get an answer for you. Well, cool. That's the wrap up for our weekly questions and feedback. So just a couple housekeeping notes here. The written versions of the Tor and Jails and OpenBSD router tutorials have been given some small improvements and fixes. So if you'd like to refer back to those, if you were going to use those, they have been updated. The Podrier and PackageNG tutorials have also been updated to reflect some of the new changes in PackageNG 1.2 and the repository syntax.
Nice.
In addition, of course, all these tutorials are posted in their entirety at BSDNow.tv, which includes today's huge ZFS one, which we didn't even really get into.
We only
everything
touched
on
about
that.
half of the parts, and we even skipped some of that stuff. There's the full outputs, and in the tutorial, the written version of the tutorial, it all worked perfectly. Although the one problem we had during the live show, I got a Skype message from George Wilson telling me how to fix it.
Yep, there you go. So cool. So yeah, definitely check that out. As usual, send your comments, questions, show topics, ideas, stories to feedback at bsdnow.tv, and we'll use that for preparing for next week's show. If you have any cool stories about how your company uses BSD, interesting things you've done, or crazy network stories or cool projects you've been involved with, go ahead and send that to us too. You never know. We might be able to put that on the air. As usual, you can watch live Wednesdays at 2 p.m. Eastern, 1900 UTC. And just as a little aside, we did a little bit of an experiment with this week's show. The first segment we did for the opening news, that was coming on my end from a PCBSD box. We were able to run Skype 4 on PCBSD finally, ditching Windows. So
and that worked great until we went to do the interview, and that requires Skype version 5 to do multi-way video.
Curse you, Skype. So anyway, we're making progress on that. Like, I don't want to turn this Windows machine on ever again. So anyway, as an aside, that we did manage to pull that off today. So work is ongoing.
Awesome.
But I hope you guys enjoyed the show this week. We really appreciate having you watch or listen, depending on your preferred format. And be back with us same time next week. Thank you guys very much.